Okay, here we have section 1.10, which is inequalities. This is the last section before our unit exam. So this is the last type of the last subject we're gonna cover in our first unit here. So this is all about writing, solving, and graphing inequalities. Okay, so let's look at we have simple inequalities, and then we'll look at compound inequalities. Okay, so let's look at our simple inequalities first. We're given 3 examples here, and we're given the graphs for each. Okay, so things to remember to look for is your circle. So what number is your circle on, right? Is your circle open and closed? And then which direction is your arrow pointing, okay? And we are going to be writing solution sets to inequalities in 2 different types of notation. One is, well, says set notation, but I will always call it set builder notation. So if you hear me say set builder, that's what I'm talking about. And then interval notation, okay? So in set builder notation, we are always going to open with a curvy bracket, and then we're going to write our variable. So it doesn't tell us what our variable is here, but I will just call it x. So we're going to say all values of x such that, we just have this vertical bar here. And then the second half of the set builder notation is just going to be the inequality representing your solution set here. So you can see we are talking about all of the numbers from here to here going on forever. Okay, so we are going to say all values of x such that x is greater than or equal to 3. Okay, so that's the inequality that represents what's highlighted in blue here, and what the graph is representing. So all values of x that are greater than or equal to 3. So it's greater than because we start at 3 here, and we're going in this direction, we're getting bigger, okay? And we say greater than or equal to because our circle is closed here. So that is an indicator that we are including the value of 3 in our solution set. Okay, and then after the inequality, we'll just close with the curvy bracket. Okay, to write an interval notation is where you list the lower bound and the upper bound of your solution set. List one of them, comma, the lower one, comma, the upper one, and then you're giving either brackets or parentheses on the outside depending on whether or not the solution set contains that value. Okay, so x is greater than or equal to 3. The way that we write this in interval notation, we're going to list our lower bound. So x is bigger than 3, so 3 is going to be the smallest it can be, and then it goes on in the positive direction forever, so we represent that with infinity. Because 3 is included in the solution set, we give it a bracket. If it was not included, we would give it a parentheses. And because infinity isn't really a number, so we can't say x is equal to infinity, it just represents a direction that we're going. It's never technically including infinity because it's not a number. So we will always give infinity and negative infinity a parentheses. Okay, so let's look at the second one here. Our graph for number 2, we're looking at everything from -6 down. Okay, so in set notation, we're going to open with a curvy bracket. We're going to say all values of x such that x is less than -6 and close it. Okay, so we said less than because we're looking at -6 here, and then everything smaller than that is included, as you can see on the graph. And then we did less than instead of less than or equal to because of the open circle we have here, which indicates that we are not including -6 in the solution set. So we're including -6.00001, but not -6. So everything up to -6, but not including it. Okay, so writing an interval notation, we'll write our lower bound, which we're going in the negative direction forever, so we represent that with negative infinity. Our upper bound is 6, Infinities will always get a parentheses, and then since 6 is not included here, we'll also give a parentheses to that. There's interval notation for that. Okay, set builder notation for the graph of number 3. So the graph of number 3 is showing that we're going, covering all of these numbers, and then with the arrows extending in each direction forever. So the way that we would say this would be all real numbers. So if we get a solution that's all real numbers, this is what the graph looks like. If we were to write this all real numbers in set notation, we would open bracket, curly bracket, all values of x such that x is an element of the real number set. Okay, so this little curvy E thing just means is an element of, and then we say the real number set, meaning every number that is contained in the real number set, or all real numbers. In interval notation, we'll still list our lower bounds. We're going in the left direction forever. We're also going in the right direction forever, which would be our upper bound. And then they get parentheses because the infinities always get parentheses there. Okay, so I don't think this tells you, this does an example on no solutions. So if we were, and we will come across this in inequalities, but if we were to come up with no solutions, okay, in set builder notation, we would write this, all values of x such that x is an element of the empty set. So that is a circle. It's not a zero, it's a circle with a line through it. The empty set doesn't contain anything. So that's how we would write no solutions in set builder notation. And in interval notation, I don't believe there's a way to write no solutions in interval notation. So if you're being asked to write in interval notation and it's no solutions, you can just write it out in words here. Okay, but if it's set builder, this is how we represent that in set builder. Okay, so let's look at, we just looked at the simple inequalities. Now we're going to look at compound inequalities. Compound inequalities are just your solution set has more than one condition. Okay, so more than one inequality or condition, and they are either of the and category, so this solution and this solution. So that means that x has to be a member of this set and this other set, whatever those may be. Or we can have the or type of compound inequalities, where we say x can be a member of this set or it can be a member of this set. Either one or the other, and then the and is x has to be a member of this one and this one, both. Okay? So let's look at this one. Number 4 looks like this is an or type. So x can either be in this set, represented by this graph, or it can be a member of this set. Okay, so the way that we would write this in set builder notation, we'll start it the same way as the other ones. Open curly bracket x, all values of x such that, and then we're still going to put the inequalities here in the second half, but because we have an or compound inequality, we're going to be writing 2 separate inequalities with the word or in between them. Okay, so let's look at the left one here. This inequality is x is less than 1, okay, or, and looking at the right side, we have x is greater than 5. Okay, and these are both open circles, so we don't have any equal to symbols underneath our inequality symbols. And that's it. We just have this inequality or this inequality. All right, and then writing this in interval notation, we're going to write 2 different intervals, and then we're going to connect it with a union symbol. Okay, so let's look at this left one first. This x is less than 1. So writing this in interval notation, our negative bound is going to be negative infinity, so we'll give that a parentheses. And our upper bound is going to be 1, also a parentheses because it's not included. We'll write this union symbol, Okay, and then looking at our second inequality here, x is greater than 5, we're going to do our lower bound is going to be 5 here. Upper bound will be infinity. Both of these will get parentheses because neither one of them are included in the set. Okay, so this is how you combine interval notation for an or compound inequality. Okay, again, this is the union symbol. Okay, so we say negative infinity, comma 1, union 5, comma infinity. So if we were saying this in words, that's how we would say it. It's just union. Let's see. There was something I wanted to say. Oh, when we do these if you're giving a solution in interval notation on a formative doesn't have this union symbol, so you can just simply type in the letter U, and then that's how I'll put my answers in for the answer key, and hopefully that will work out. As you guys have probably seen by now, it's a little bit finicky, but if I stay up to date, I can go in and correct your answers, or correct the answer key to make your answers show up right. Okay, let's look at number 5. So we have another or here, okay, because we have two different graphs here. They don't overlap at all. They're going in different directions, so we know that this is an or compound inequality. So we're going to write it just the same as before, all values of x such that, let's look at the left one first, x is less than -7, okay, open circle, so we just leave it as less than. And then looking at the right side of the graph, x is greater than or equal to 2, close bracket. And then in interval notation, writing the interval for the smaller set, we'll do parentheses negative infinity, comes all the way up to -7, union 2, oops, this should be a bracket here because we are including 2, and then to infinity. All right. Now let's look at, so our other type of compound inequality here is an, excuse me, is an and type here. So this is where we have like overlapping, this is our overlapping solution sets here, okay? So remember when I said an and inequality means x has to be part of this set and part of this set. So we're going to look at the x values that match both. So here it looks like it has to be bigger than -4 but less than 0, and it has to satisfy both of those requirements. And so that's how we represent it on the graph like that. So when we write this in set builder notation, we're going to open with squiggly or curvy bracket, all values of x such that, and then here we write this as a compound inequality. So all of our and compound inequalities we can write kind of squished together into like one statement instead of this one or this one or this one and this one. We can say that -4 is less than x, which is less than 0. Okay, so we have both of these. Inequalities, but we can write them since they're overlapping. X is between them. We can write them as the lower one is less than x is less than the upper one. Okay, so let's look at this in interval notation. So we're looking at the lower bound, which is -4, and the upper bound, which is 0. It does not include either of these, so they're both going to get a parentheses, and that's it. This is the interval over which x can be found. It is between -4 and 0, but not including either one of those. All right, and looking at the last one, this one is also an and type. So we have all values of x such that -1 is less than or equal to x, which is less than 8. Close curvy bracket. So we do have a closed circle here, so we have the equal to underneath the less than symbol here. Writing in an interval notation, we have -1 to 8, a bracket on -1, a parentheses on 8. Okay, so hopefully this was a review and it's just refreshing your memory from math classes past. Because we're not really going to spend a whole lot of time on this. We want to look at solving these inequalities here. So this was all just on notation. So actually this has kind of been a long video, so I'm going to end this video and make a second video doing a couple example problems.